My name is Brooke Willin.
I'm Kevin Lloyd.
And my name is Joselyn Castillo, and we're going to be doing the Arabica coffee cherry harvester, and our advisor is Dr. Levy. So the overview for today is what we're going to talk about is the problem statement, as well as getting a better visual of the coffee plant characteristics and the manufacturing construction behind our prototype, as well as our results and our future work. So the problem that we currently want to overcome is the fact that current farmers use these two methods right now in some of their small farms. What they use to pick the cherries, one of the methods is by hand, which is too slow and too demanding. And the second method is by stripping the harvest. This sometimes ends up damaging the plant as well. So what we wanted to create is a machine that is able to facilitate the picking without damaging the plant. Our goals to keep in mind were that we wanted to project 70% or more of the prime matured berries, as well as to making our prototype light enough to make it portable for the laborers to use. In general, what we wanted to create is a machine that is able to increase the quantity of berries without decreasing the quality of the coffee.
Okay, so a couple of important Arabica coffee cherry characteristics we took into consideration when designing a mechanical harvester was the fact that the strength in the attachment to the stem of the fruit becomes weaker as it matures. It also becomes more distinguishable to the eye as it becomes red from its initial green state, and it also grows in size as it matures, so this will facilitate the picking process.
So to get an overview of how large the plant actually is, it's actually the size of a human. It grows about that tall, and everything's within arm's reach, all the berries. And here's an up-close picture of the plant and how the branches grow. It is widespread, apart from one another. Also, you can see how the berries grow themselves. The red and the green are all mixed in with one another in about foot increments and in clusters. The total diameter of the plant is about 3 inches.
So some of the global issues that we wanted to go ahead and focus on was the manual labor, time consumption, and some of the environment conditions that affect our prototype. As mentioned before, picking the cherries by hand is too time-consuming and too demanding. So we want our machine to be able to decrease the statistics, such as during coffee season, it's normally the laborers are 40% kids, as well as the laborers spend 10 plus hours working in the field to produce just the minimum, to produce minimum wage, to produce their quota of 100 pounds or more. Another factor of global issue that affected our project was the fact that we are focusing in South America, and most of the Arabica coffee cherries are grown in mountainous areas. Therefore, we want to make sure to emphasize that we want to keep our prototype light enough for them to carry it, because one thing to remember is that most of these laborers are carrying all their equipment on certain animals. Therefore, we want to be able to have the prototype light enough for them to carry it, to pick the cherries, and then have it come back.
So a couple of engineering standards and government regulations we had to consider when designing our product was the guidelines set forth from the Colombian Agricultural Society. Also, we took down some considerations of the coffee plants from the United States Department of Agriculture. And the two most important government regulations that affected us were the regulations on the importing of coffee plants from a foreign country into the U.S., and also the sanction on being able to purchase a tree with fruit on it in South Florida due to the fact that they're trying to eradicate the fruit fly.
So keeping our goals in mind, we created 2 different designs. The first design would be planted along with the coffee seeds, and then it would grow and it could vibrate and with enough frequency to make the red cherries fall. However, coffee plants take about 4 years to grow, so instead we came up with a rotating cylinder with pins located in the vertical and horizontal axis that would basically knock the plant off, or knock the berries off. However, we decided that that would probably damage the berries, so we came up with instead, still keeping the rotating cylinder, springs inside. So those springs can be adjusted to the width of the plant, and as it rotates, the springs will displace the fruit. Holding the cylinder are 6 wheels, and then holding everything together is PVC pipe. And what you would do is you would put the branch through the tree, and it would rotate and take off the ripened fruit. So some of our manufacturing components were the springs, which is on the inside of the cylinder. Those springs were had plasti dip on the ends so that it didn't damage the plant, being that the springs have sharp edges. Also, those springs, when facing one another, they interlock so that there's always a constant contact with the fruit. Moving on to the wheels, there is one driving wheel and 5 guiding wheels. The most important aspect to keep in mind for this is that we needed bearings. So we chose skateboard wheels for our prototype because it was very important to have a consistent rotation that's frictionless and smooth. In addition, we used PVC piping. It was good for us because we could optimize the angle at which the cylinders touch the wheels touch the cylinder, as well as it's lightweight and it's actually like a built-in handles for the laborer to hold. And here's a photo of Joselyn manufacturing some of our pieces. In terms of maintenance, springs would need to be maintained because they will deform over time and stretch out, as well as the battery. The battery we chose for our future design is a rechargeable battery so that it's easier for the small farms to maintain, but eventually the batteries will deplete and you would have to change those.
So our entire design is geared towards generating a force that will strictly remove the ripe cherry and will keep the unripe berry on the plant to be removed at a different time. The first way we address this constraint is through torque generation. Above you see that we use Euler's equation in order to figure out the required angular velocity that will generate this force. On the left-hand side, you'll see that we expect our inner cylinder to come into contact with the restrictive cherry fruit removal forces at 3 different locations at any given time, and this is due to the fact that we have 3 inner components. From there, we solved for the angular velocity, and then we were able to solve for the force of friction required between the 2 cylinders that will drive the cylinder at the required force to remove the cherry. From there, we solved for the torque for both respective cylinders, which led us to find the power required to produce this force to be 27.1 watts. The next most important component that is dedicated to strictly harvesting the ripe berry is the springs that come directly into contact with the fruit. By taking these springs as cylindrical cantilever beams and manipulating the governing equations to solve for the stiffness coefficient, we were able to find springs and subsequently the material that these detaching fingers can be made out of that will stay stiff if coming into contact with the ripe berry, which will produce a force of 5.7 newtons, and will deflect if coming into contact with a force larger than that. Specifically, the force necessary to remove the unripe berry, or perhaps if it were to come into contact with the stem, which it could potentially harm the plant if it doesn't deflect out of the way. And we found that a thermoplastic polyurethane exhibits a modulus of elasticity close to the one that we calculated that would work well as a detaching finger. So here you see a cross-sectional view of our inner component, and at the respective locations is where we expect max normal shearing and bearing stresses to occur. By using the max forces that we expect our components to exhibit, we were able to calculate these stresses, and by using the yield strength of the materials chosen to make these components out of, we were able to find factors of safety. At the bottom, you'll find the smallest factor of safety that we found, which is 112.7, which is a very desirable design factor, and that's the location of it. The reason for it being so high is because we're producing such small forces onto components that are made out of steel and aluminum. Also, another very important stress that our design exhibits is located at the point between contact of both cylinders, that being the rollers and the inner cylinder. So these stresses are called Hertzian stresses that are similar to the stresses that railroad tracks exhibit when they come to contact with the train rollers. And so this is a specific equation used to generate the max stress that a cylinder-on-cylinder contact would generate. And the max stress that our particular situation would exhibit is 9.98 by 10 to the negative 6 pascals, which is very low and thus contributing to the fact that it won't fail at this point in design.
So in terms of testing, our procedure was to count how many ripe cherries were on the branch as well as the unripe cherries. And then we ran it through the machine and we saw how many were displaced. In our third trial, which gave us the best readings, we had adjusted the springs, so it reduced 75% in fruit removal rate. And fruit removal rate is the industry standard of how they measure how efficient the machine is. Also, the average was 58% across all 3 trials. We are confident that we could reach our goal of 70% if we had more testing. At the moment, we only have 3 branches due to the regulations. And here's a video of us testing it. Kevin is inserting his hand into the cylinder. And here you can see it displays 2 red fruit that I panned down to. They're on the floor. There's the 2 fruit. No green were displayed until after the fact, and this ran for about 11 seconds. So for our cost analysis, for the prototype is about $125 total. And then if we were to take into account true real-life labor costs, it would be around $12,000 and would profit $1,200.
So basically, some of the work that we want to do for the future is definitely scale it down to smaller size. This will help us specifically on reducing weight as well as increasing the portability for our laborers. And it also will decrease the power needed in order to generate the specific forces. Another part that we want to focus on is the power source. We want to be able to see if we can make it more renewable energy, such as maybe solar. And for safety considerations, we want to be able to add a switch that is sensitive to when you trigger it. That way, just in case if there's an emergency, like your hair gets stuck in it, or clothing or a type of glove that gets stuck, it automatically turns off when you release the button. We learned a lot throughout our lessons while working together throughout our project, some of them being the knowledge of coffee characteristics that we didn't know before, as well as being able to take everything that we learned in school and apply it to real life situations when building a product, such as in designing, assembling, and manufacturing. Last but not least, one of the best lessons that we learned was how to work in a team setting and how to overcome certain obstacles that are thrown your way, that sometimes you just have to work in a team to get over it. Not only will that help you in a student life, but also once you start our own professional careers. And then we want to say a huge thank you to our advisors, specifically Dr. Levy, for helping us and guiding us through the project, as well as Dr. Tosunoglu and Mr. Zuccarelli, who have been a huge help to our project, and to Dr. Murray, who was a coffee expert who helped us throughout the whole process of it.
There's coffee in the back if you guys want. Any questions?
I would like to see it go.
Oh, well, this one, we had the video because after we kind of dropped it a bit, and the cylinder came out of proportion, so it doesn't spin correctly now.
Oh.
But it did.
I have to admit, you scared me when I saw that hand going down.
Was it scary?
Yeah, actually, it was my hand, and I wanted to show that this doesn't harm my hand, so.
You ever heard of machine guarding?
Yeah, so it doesn't hurt because the type of forces it produces are very small, because that's the type of force needed to remove fruit.
So it
So,
doesn't
but my
spin.
question is this, so on the coffee tree, the branches come out, I mean, you don't take the branch off and put it in, you have to put.
No,
it's
so
the
yeah,
of course.
Of course.
Right, so our test was very limited in what we were able to actually test.
Yeah, because you couldn't
Since
get
we didn't
coffee.
really
Yeah,
have
if we had
the
access
coffee
to a full
plant
plant
to
and
be
a
able
full
to put
field,
it,
we
we
can
had
get
to
some better
pretend.
numbers of how long it would
Yeah.
take.
However,
How long it would take to harvest a full tree and stuff.
So what's the goal of green to red? What's the allowable rate of green being taken off and red left on?
Right, so the hopes is to not have any green harvested because those are unripe, and it reduces right now the quality of coffee that we even drink today. So they don't have a targeted goal, it's just as little as possible and to harvest more red as possible.
So
Basically, our
when they do it by hand, then it's what, 100% red and 0 green?
So, well,
Right.
when they do it by hand, they either strip the whole branch, so then you get
Oh, yeah.
both types of
Yeah.
berries.
They don't pick at each one?
Well,
Or
like-
they could pick the reds, however,
when they pick the red, sometimes at times, though some of the greens fall
Oh,
off
yeah,
as well. So you still are left, after the process that you're picking, left distributing out between the red and the green.
and we also wanted to mitigate the hand labor that goes behind picking each individual branch per tree, per row, for the farm.
And how did you calculate the amount? Was it just an experimental method that you used to calculate how much force you needed to knock down the red, or do you actually, how do you?
Yeah.
We had the values.
Yeah.
Yeah, actually, that's found through research that we found looking. It took us a long
Really,
time
somebody
to find.
did
Yeah.
that?
Yeah,
There was,
it's
like,
actually a whole
research we found.
process that where they remove grapes, they remove coffee cherries, remove all types of berries, and they have to use a hook force, and they hook it up at 3 different locations, and then gradually increasing the force, and at the point where
So they had that, they had that.
displaces.
in-
Yeah.
Right, so
Yeah,
that we found the
finally.
research directly. If we had the tree, then
It would've been better.
finding our own version of it.
Now, would you attach a bag to the bottom of this as you went up the thing, so all the berries would go into a
Yeah, we
bag?
did take that into consideration. We didn't want to close off the cylinder though, because we wanted to span the whole branch. So we wanted to keep both ends
Oh, yeah.
open. But in the cylinder itself, the berries get caught there and then they could dump it into a bag.
Or we also wanted to just lay a net at the bottom.
Yeah,
and
which
just
is easier.
gather it and drop it into your
The whole thing.
Do green berries off the tree ripen to be red?
No.
They don't ripen off the tree.
Yeah.
They don't ripen off the tree.
So they become like not
Well,
They
useful.
spoil it.
Yeah.
And when you strip harvest, which is the other method, it actually harms the plant, and there's a lot of problems with it. So to strip harvest, you have to wait till you get to 75%
Right.
ripe. So that means that some of them are overripe, some of them aren't ripe, and you're just wasting all those fruits. So
And you gotta
basically,
keep in mind too also during that it takes about 4 years for the plant to regrow
Yeah, if you're harming.
to its
Mature.
normal, to mature bean, so therefore, cherries. So therefore, you also wanna keep in mind that that's not the best method to use.
What country is this primarily used in? I know Costa Rica grows a lot of coffee.
Yeah.
Colombia does.
We focused on Colombia.
we wanted to focus on places that weren't so flat, due to the fact that for flat terrains, there are huge machines, very expensive machines that exist for
The
it.
shakers?
That use, yeah,
Yeah,
exactly.
exactly.
Shakers. And this is something that's very portable, that can be used by individuals.
And
And
scalable.
yeah, it's also very scalable from our prototype version to a better version.
I have a comment, I'll have a greater appreciation for my morning coffee.
Us too.
Think about it, right?
You can brew right out of plant. Thank you very much.